Hello, so now we're going to look at some other public blockchains. Starting with Polkadot, which is a platform for building and connecting public blockchains. So its mission is to enable a completely decentralized web to make blockchains inoperable. That means they connect with each other. So there's this relay chain, and parachains are rather like the beacon chain and shards in Ethereum, but also there are these bridges. So this illustrates a bridge to the Ethereum blockchain. There could be another bridge to the EOS blockchain or the Bitcoin blockchain. So it's supposed to be the blockchain of blockchains. So Gavin Wood was a founder of Ethereum, which he makes quite plain from everything he puts out, but he split with Vitalik a few years ago, and then he went on to do parity and various things, and it's not exactly clear what he's doing right now, but he did start Polkadot. This is him, quite different to Vitalik's website. It's not nearly as well known as Vitalik. I mean, if you just type in Vitalik, I think his website is vitalik.sh. That's it. Oh, no, hang on. I'll just put in Vitalik. Oh, I probably spelt it wrong. So wiki, there he is. Doesn't he look amazing? Anyway, we're going to see a video of him later. Okay, back to the lecture. So security in Polkadot, I forgot to mention on the previous slide that Gavin actually launched this new coin, DOT, with a very large ICO, 1.2 billion. You can see news about it there if you have a look. So that's him talking about, this was in June 2019, so not long ago. Okay. Security is via proof of stake. So validators secure this relay chain using the consensus, as I mentioned before for Ethereum. But Polkadot has three new types of participants: the nominators, who this is like a delegated proof of stake, quite different to the completely random proof of stake, where nominators actually select good validators. And collators monitor these parachains, a bit like the shard chains, to collate the information collected by those chains. And fishermen monitor the entire network, the relay chain and all the parachains, like policemen. So if there's any security problems, that's where the fishermen will come into play. IOTA is another public distributed ledger, but so its security and accuracy is also maintained cryptographically, but it's not a chain. For scalability, instead of trying this bottleneck that's shown here, there's what's called the tangle. Transactions come along and then they get into this tangle. I'll explain what that means in a minute. So each individual transaction is validated. So it's not really a blockchain. Unapproved transactions are called tips. So for example, this one on the right top here and this one below it, these are two tips. They haven't been approved. Each incoming transaction needs to choose two tips to approve. So if I come in here, I might choose this one and this one, for example. Let's have a look at this simulation. It's quite neat, I think. Here we are. Let's increase these a bit more to make it more of a tangle. That's a big tangle there, maybe it's a bit too big. Anyway, so these grey ones are the tips. So this tip approved the two red ones on the left here, but this red one and that red one, click on there again, approved other ones. So that if you've approved a transaction that's approved a transaction approved, so the transactions are like sort of distributed. They carry on until this last transaction here has been approved by the entire tangle. But so if you click on any one here, you can see that this one approved those two transactions to the left, and all the red ones are the ones that it approves. And it was approved by this transaction, and also, actually it's been approved by 3 transactions who have themselves been approved by other transactions. So there's 1, 2, 3, 4, 5, 6 approvals for this particular transaction. Apparently the strategy that you choose for approving the tips is quite important. Very complex. So in fact, I was learning about it on this Medium post. There's 5 parts to the introduction. If you're interested in choosing a tangle as a topic, then yeah, you should have a look at that Medium post. Maybe do some simulations. Security in the IOTA tangle is controlled at the moment by a centralized coordinator. So it's very easy to scale, but it's not actually a permissionless or decentralized distributed ledger at all. But once the tangle does get large enough, the plan is to remove this centralized coordinator in what they call very neatly coordicide.
The IOTA Foundation is proud to present the blueprint for coordicide, a crucial step towards the first permissionless and scalable distributed ledger technology. In its infancy, IOTA's underlying data structure, the tangle, was secured by a temporary component known as the coordinator. With coordicide, the planned removal of the coordinator is achieved, replacing it with new security mechanisms that allow IOTA to become fully decentralized and geared for the new internet. One of these is a revolutionary voting module where consensus is reached through proactive communication in the network. We call it Shimmer. In the blueprint, we unveil all the modules and the freedom they bring for building and integrating. Because at the end of the day, IOTA is about freedom.
Okay, now hang on, wait a minute.
To transact data and value without fees.
So you can see where the ICO money went. There was a lot of marketing at the end there. But it's all about the Internet of Things and so forth. Very, very futuristic. But actually it's built with some really sophisticated mathematics. And the IOTA website has a lot of excellent information on how the tangle actually works in different tutorials and modules. So I'm pretty keen on IOTA. I've also got some DOT, but I think IOTA is probably going to be one that eventually becomes really important. I also have some Ripple. It doesn't cost very much. It's only about 2 cents for a Ripple. So the Ripple blockchain is a cross-border payment mechanism. It's designed to rival this SWIFT system, which I'm sure you know about because you use it for bank transfers. If you pay on your phone. But SWIFT is owned by the US, and actually it's used as a way of the US imposing all sorts of sanctions, which is one of the reasons why the Chinese central bank and many, many other central banks are now moving to what we call CBDCs, central bank digital currencies, to enable these cross-border payments. And Ripple should become the the independent cross-border payment mechanism which digital bank central currencies can use. So you've got, you know, this digital currency goes to Ripple and then goes to another digital currency. That's the idea of Ripple. But Ripple isn't mined, it's just sort of released periodically. It's very, very quick. It's something like 1,500 transactions per second. And the consensus algorithm is a unique thing called the Ripple Protocol Consensus Algorithm. And again, it's like a bit like proof of stake, but not exactly. You can find out more about it if you have a look here. Slightly dry, but very thorough, and not too sophisticated, like some of the things that are on the internet about blockchain. So each server has a network of trusted validators called a unique node list. And the consensus proceeds by several rounds of voting on nominated transactions. And then they drop the ones that have got the too few votes, and they vote again until transactions are approved. It's apparently very, very quick. But yeah, we just mentioned these three blockchains. Well, Tangle's not a blockchain, but you know what I mean. But there are so many of them, and they all use different types of consensus algorithms: proof of stake, delegated proof of stake, least proof of stake, practical Byzantine fault tolerance, directed acyclic graphs, proof of capacity, proof of importance, proof of all these things. So yeah, there's a lot to learn on blockchains, but it's important because it is the future. Okay, I'm going to stop this video now, and the next one is going to be on smart contracts.